Today our session topic is matrix. So this topic, matrix topic, is also very large topic, vast topic, but with this limited time period, I will explain most important sections of this topic. So first, when I move into the introduction about matrix, this is very important because matrix algebra has many advantage. So most of the time we can use it to reduce complicated system of equation to simplify expressions, and also we can adapt it to systematic method to mathematical treatment and well suited to computers. So what is this matrix mean? A matrix is a set of group of numbers arranged in the square or rectangular array, right? Enclosed by two brackets. So we have to put the two brackets, and inside this bracket, we need to insert some numbers, right? Like a square or rectangle way. So these are some examples, right? You can see within the bracket, there is a two numbers, 1 minus 1. Next one, 4, 2, 0, 3, minus 3 and 0. Or general form in here, I have given here A, B, C, D. So, but it is, yeah. So this is the 2 by 2 matrix, right? So, however, in this matrix, right, there are main characteristic or properties. So, in a matrix, we can identify there are number of rows and columns, right? So this with these rows and columns, we can describe the dimensions or size of matrix, right? Order of our matrix. So two numbers, that means row multiplied by column, we used to name that, we used to identify the size of the matrix, right? I have given here some examples. First one, you can see it is 3 into 3 matrix because number of rows are 3. There are 3 rows and also 3 columns. Then we can say its size, that matrix size 3 by 3. And the second one, in the second example, you can see there are only 2 rows and 1, 2, 3, 4 columns. So therefore, that matrix size is 2 by 4. And the last one, given example, there are only 1 row and 2 columns. So therefore, it is 1 into 2 matrix. So then when we move to the, here I have given the general form of the matrix. So this matrix we know denoted by the letters or elements, right, inside the bracket. So in here you can see I have given the name for the matrix A and M into N. That is the size of this matrix. That means number of rows are N, number of rows M, and number of columns are N. You can see this common or general method of the matrix, right? So its size is, you can see in here, M multiple N or M into N, right? M into N. That means number of rows equal to M and number of columns equal to N. Or we can write it this way or this way. These two methods we can use to name it. And first element is A11, A12 because 1 is the first row. Right? 2 is the here column. Like that A13, up to Aij, right? Then you know I is the, I goes up to M because I is the number of rows and J is the column, J go to up to N. And then, yes, type of matrix, right? Next, you need to understand what are the different type of matrix, right? So first one is column matrix, right? Column matrix. Column matrix mean the number of rows may be any number, any integer, but the number of columns is always one, right? Number of columns should be one, but number of rows can be changed uh, uh, in the column matrix. එක column එකයි තියෙන්නේ. And you can see some examples here. And next is row matrix, right? Row matrix is any number of columns, but only one row. The matrix has only one row, right? These are the examples, right? Columns can be different number. And another type of matrix is rectangular matrix. Rectangular matrix. So rectangular matrix contain more than one element and number of rows is not equal to the number of columns. That means not squared one, right? So the different, but different number of rows and the columns. Okay, then it's become like a rectangular, right? So then other type is the square matrix. In this case, number of rows is equal to number of columns, right? So then square number has same number for the m and n, m into n, right? That means size of the matrix, 3 into 3, 2 into 2, 4 into 4, like that, okay? These are the some examples, okay? So then we can move another type of matrix, diagonal matrix, right? Diagonal matrix. A diagonal matrix means a square matrix, right? It should be squared one. A square matrix where all the elements are zero except those on the main diagonal, right? You can see in here. So the diagonal matrix mean, right? So this diagonal should have some numbers. Diagonal has numbers, but others except this diagonal, other all elements should be zero. These are the zero, right? Zero elements, this side and this side. So this kind of matrix we call diagonal matrix. And then another type of matrix is unit to identity matrix, right? These two names we use for the same one, unit matrix or identity matrix. So the identity matrix or unit matrix mean diagonal matrix with ones on the main diagonal, right? So all the elements in the main diagonal should be 1, others should be 0. You can see this example, right? This main diagonal, this one. This main diagonals elements, all elements should be 1 and other elements are 0, right? Other elements are 0. In here, these two. This is 2 by 2. This is 4 by 4 matrix, right? This one is 4 columns and 4 rows and 4 columns, right? So then this is the diagonal matrix. And then null matrix or zero matrix, right? So the word is imply the meaning also, right? All the element in matrix are 0, right? 0. So the matrix can be rectangular or the squared. However, all the elements should be 0 in the matrix. Then we call it is the null or zero matrix. Then we can move to the another type of matrix. Yeah, triangular matrix, right? Triangular matrix means, so a square matrix whose element above or below the main diagonal are all zero, right? Any side. So I'll show you diagonal here, right? One side. In one side of this diagonal, the all the elements should be zero, right? Only one per side. In this case, you can see this side uh, 0. In this case, this is the main diagonal. These are the 0. So therefore, this kind of matrix we call triangular matrix. And this one also we can divide as the upper triangular or lower triangular. I'll show you this one also. Upper triangular. Okay. So upper triangular, right? Upper triangular a square matrix whose elements below the main diagonal are all 0. Right? So this is the main diagonal. It's below. Below part is all the elements in the below part 0. This is the main diagonal. Below parts are all the numbers in elements in the below part 0. Then we call it is the upper triangular. Right? Upper triangular. So opposite of that means the other way, lower triangular we can show, right? So lower triangular is the square matrix whose element above the main diagonal are 0. Right? You can see this is the main diagonal and all the elements above this diagonal are 0. Then we call it is the lower triangular matrix. Right? Lower triangular matrix. Then, yeah, we can, yes, so the other one that is the scalar matrix, right? Scalar matrix is a diagonal matrix whose main diagonal elements are equal to same scalar, same number, right? So in this one, you can see diagonal matrix is, right? That means the main diagonal has a number, right? Others should be 0, but that diagonals numbers is same number. One, in this case, 1, 1, 1. Here, 6, 6, 6, 6. Okay, so this is the scalar matrix. This is the common way for the diagonal matrix because scalar matrix, right? So in this diagonal, all the elements are same. Similar numbers, okay? So then we can move to this one, that is first I will show, delete my drawings, right? It's okay. So equality of matrix, yeah. Two matrices are said to be equal only when all the corresponding elements are equal, right? Corresponding elements, that means same place, the elements in the same place, right? Should be same. So shall we consider this one? Here you can see 1 and here same, right? These two are 0, then these two should be 0. And this one 5, that 5 and the same place, okay? So then this kind of two matrix we called equal matrix, right? Or equality of matrix. Then we can move next one. Yeah, matrix operations. This is very, very important part comes under the matrix, right? So these are some properties of equality. That means if A, matrix A, right? Matrix A and B, if matrix A and B are equal, then we can say B equal to A for all A and B. That means A equal B, B equal A, right? If we have three matrices like A equal B, B equal C, then A should be equal to C and also all three A, B, C are equal. Right? So I think you can understand what I mean here. And Next one is matrix operations, right? You have to know basic operations, metric operations under this topic also. So, addition and subtraction of matrix, right? So, addition. So, the sum of the difference of two matrix A and B of the same size yield the matrix C of the same size. That means when we to add the matrix, two matrix would be same size, 2 into 2 and 2 into like the 2 by 2 matrix, and other should be 2 by 2, right? One is into 3 by 2, then other one also is a 3 by 1. Okay, so then otherwise we cannot add, right? So the size should be equal, and answer mean when after adding two matrix, then we can get the same size uh, matrix also, right? So you can see in here, right? If we have two matrix A and A plus B, then B plus A is similar, right? And also we have three, it is also same, right? So I'll show you here. I have given one example. Uh, already apply this. Addition operations, right? Adding operations. So just think this is matrix A, right? And its size is 2 by 3 because 2 rows and 3 columns. And then we need to add it to the B, and therefore B also should have 2 rows and 3 columns, right? These two should be equal, right? Size of the two matrix which we want to add should be equal size. And also after we add in two matrix, we can get the same size matrix. That means 2 into 3. Okay. So in here you can see first element we need to add 7 and 1, right? So then the answer is 8. We have can put in here like this, okay? And then second element, this one, 3 and 5 we need to add. Then it is equal to 8. And next we need to add minus 1 and 6. When we add in these two, it is equal to plus 5. And then 2 and minus 4 we have to add. Then when we add in these two, minus 2 is remaining, right? Our answer. And when we add in minus 5 and minus 2, then altogether minus 7 we have to put in here. And finally, we need to add this 6 and this 3. Then it is, we have to write in here, it is plus 9. Okay. So then this is the answer or after adding A plus B. Okay. And I think it is very easy. You can understand very clearly that part. And but this is another one. Yeah, the matrix operations minus, right? Deducting one from another one, right? So in here you can see I have given again two matrix. However, this is okay, you know, when we, another rule in here, when we add in zero matrix to the A or zero matrix add in A, however, it is A, A man, zero matrix add color, right? When we minus in the same matrix from the same matrix A, from matrix A, when we deduct in minus matrix A, then it's become a 0. So can A minus A matrix corresponding to the A minus A ij elements, right? So then in here minus in, right? So then if it is like this, that mean we need to deduct this second matrix from this first one, right? So deducting matrix is very similar to the way of we adding, right? Now we have to minus, right? So 6 minus 1, you can see 5 in here. 4 minus 2, then it become 2 here, 5, remaining t, right? 2 minus 0, answer is 2, then we can put in here. And 3 minus 1, then it is 2. And 2 minus 0, then it is 2. And 7 minus 8, it is minus 1. Okay, so then this is the answer when we deducting the second matrix from the first one. So plus and minus, adding and minusing or deducting metrics are okay now, right? Shall I move my next slide? Yeah. Scalar multiplication of matrix, right? Scalar multiplication mean matrix can be, we can multiply it by the scalar or scalar mean constant value, right? We can multiply our given matrix by the constant value, right? This is also very easy. Here you can see again this both, okay, that means both is similar. Both mean what I mean both. When we multiply any number or any value from our matrix A, shall I put in here K like this? Okay, K. And it is also equal to A multiple K. Right? This K is constant value. Right? This K is K ඉස්සරහට දැම්මත් පස්සට දැම්මත් okay කියලා කියන්නේ because it is multiplication. Okay. So then given matrix is this one and okay, so same thing I have shown in here. That means if our matrix is this one, okay, if our matrix is this one, we can multiply it by the scalar. That here I have taken it as the 4, right? We can multiply this one. And also same matrix we can multiply by 4, right? However, these two similar, this one and this part similar, and this is the answer. Answer means we need to multiply all the elements inside in the matrix by this 4. Okay. So then 4 into 3, 12. 4 into minus 1, minus 4. 4 into 2, 8. 4 into 1, 4. You can see I have point it in with my pen. Okay. 2 into 4, 8. Minus 3 into 4, minus 12. 4 into 4, 16. 1 into 4, 4. Okay. Then these are the properties of this multiplication. That means if we have two matrix A named A and B. So when we add in A plus B and then we multiply by the scalar or constant value, it is also equal to when we multiply it matrix A from the by the constant value and then matrix B multiplied by the constant value when after we add in these two together. Both are okay, right? So same thing we can write this way. That means first we add, if we have two, right? Two scalars K and G. So it is like this, okay? I think you can go through this slide and try to understand, right? And because we need to discuss more things under this, okay? So I will move the next part. Yeah. Multiplication of matrix, right? So this is very important because when this most of the algebra parts, right, sections we can use, right? This or we can apply this multiplication rule or multiplication of matrix for our mathematical to take some mathematical solutions, right? So the here multiplication mean product. We know the product of two matrix is another product of two matrix is another matrix, right? So then two matrix A and B must be conformable for multiplication to possible. That means there are some conditions, right, required to, there are some conditions should have two matrix to multiply, right? Otherwise we cannot, because any kind of two matrix we cannot multiply, right? So because we have to first check whether required requirements is fulfill the given matrix, right? What is this requirement mean? Okay, so two matrix, right? The where we are going to multiple, right? First one, columns. Number of columns should be equal to second one rows. Second matrix rows. Right, so then after then we can multiple both. right? After we multiply in both, our final answers matrix size should be equal to 1 by 1 in this case. 1 by 1 mean what? The first matrix uh, number of rows and second matrix number of columns should be equal to the final answers matrix size. Okay, so I'll show you it, right? You can see first matrix, right? So if it is A, it's not, according to this given example, its number of rows equal to 1, number of columns equal to 3, right? Second matrix, number of rows equal to 3 and number of columns equal to 1, right? So multiple the requirement, or we can multiple this. It is possible to multiple if the matrix A number of columns should be equal to number of rows in the second matrix, right? In this case, 3 and 3. Then after we multiply in these two, then our answer matrix size should be this 1 and 1. That means again, first matrix number of rows and second matrix number of columns, right? So I'll show you it with another example. Okay, so here, go through this one, right? So just think B, B matrix as a, according to this given size of that matrix, right? In this B matrix, there are 2 rows and 1 column, right? Second matrix B has 4 rows and 2 columns. To multiple if it is possible to multiple these two, these first ones number of columns should equal to number of rows in the second one, but in this case it is 1 and 4 not equal, right? Therefore we cannot multiple these two matrices. In second one you can see 6 and 2, that means matrix A has 6 rows and 2 columns. We have to check this one. And B, second matrix has 6 rows and 3 columns, right? So to add the multiple, it is possible to multiple these two. These 2 and 6 should be equal, but these 2 are not equal. Therefore, we cannot multiple these two, right? When we move to the here, you can see in here. So, matrix A has A size is 2 into 3. That means A has 2 rows and 3 columns. B has 3 rows and 2 columns, right? In this case, the requirement is number of rows, sorry, number of columns of the first one should be equal to number of rows in second one. It is okay because in this case, A has 3 columns and B has 3 rows. It is okay. Then we can multiple A and B, and final answer, or after we multiply in A and B, we can get the matrix. That matrix size should be equal to 2 into 2, right? Because that is in the first one's row number of rows and second one's number of columns. Okay. So when keeping this in your mind, then you can multiple given matrix, right? So shall we do one? Yeah, this is the common way, right? So when keep in your mind this one, no understanding this properly, so then you can apply this multiplication for the any to multiple the any kind of multiple the any possible 2 or 3 matrix, right? So I'll show you here, right? Yes, okay. So in this example, you can see first matrix we name with A, right? So then the first element is A11, right? That means palavini row ekai, palavini column ekai. So A12 mean first row and second column. A3 mean first row and third column, like that, okay? So we can name it A and B also. Then final answer this one, okay? So now we can check again, what is the size of this matrix? 2 into 3. right? 2 into 3. This one 3 into 2. Then 3, 3, okay. Then we can possible it, and 2 and 2 should be here, right? I'll show you it. First one is 2, no? 2 and 3 rows, right? Second one is 3 columns and 2 rows. Sorry, 3 rows and 2 columns, right? So then if these 2 is equal, then we can multiply. And our answer should be 2 into 2. This one, okay? So then how we can multiply? You can see this, right? First we have to multiply this one, A11 into B11, right? A11 into B11. So this is one, right? Then we need to add, right? A11 multiplying by B21, right? B21. Okay, that is the second one. Then we need to add multiplying A13 and 31A, right? That is, then after adding all these threes, we can get the first element. Okay, this is the first element, right? For the second element, we can, if this is second one, we can take, right? How we can get the second one, right? Again, we have to multiply this A11, right, into A12, right? This one. And second, next, we need to add that value to the multiplying A12 into B22. And then A13 multiplied by B32, right? So then after adding all these things, we can write it the second element 1, 2 like this, okay? And then we need to get another one, right? That means the third one, third element, how we can get, then we have to move to the second row, right? That means A21 and B11 we need to multiply, right? Then add A22 multiplying by 21 and add A23 multiplying by 31. Okay. So then it is this one. Okay. Then the final one, final element we can get when multiplying by again the second row values in the second column, right? A21 and B12 and A22 and multiply by B22, right? Next we need to add after multiplying A23 and B32, right? So then adding all these multiplied value, then we can get the C22, right? That is the way how we can apply this multiplication. Now we can do the one example, okay? So I have given here one example. Yes, okay. So now this is the example. And okay. So you can see that then first metric is size is 2 by 3. Okay, 2 by 3. Second one is 3 rows with 3 by 2. Okay, that means this one and this one equal. That means we can multiply it. Okay, and our after multiplying we can get the 2 by 2 answer. It's right. Okay, so I'll show you how. So then first one make a gannapi 1 multiple by 4. You can see plus 2 multiple by 6 here and 3 multiple by 5. Right? So that is the first one. 1 into 4 4, 2 into 6, 12, 3 into 5, 15, 15, 12, 4, then all together 31. You can check it, right? And next, right, 1 multiplied by 8 here plus 2 multiplied by 2, this one, and 3 multiplied by 3, this one, right? So then we need to add after multiplying. 1 into 1, 8, 2 into 2, 4, 3 into 3, 9, 9, 4, 8. Altogether 21. Okay. Yeah. And then next one, 4 multiplied by this 4, right? You can see. And the next, this 2 multiplied by this 6, right? Here. And this 7 multiplied by this 5, right? This is same. Then finally we can get 4 into 4, 16, 2 into 6, 12, 7 into 5, 35. All together, adding after all three numbers, we can get 63. Then final element we can get multiplying this 4 into this 8, right? 4 into 8, this one. And this 2 into this 2, right? And this one. And this 7 into this 4. This 3 value. 7 into 3. Okay, so then you can multiply 4 into 8, 32, and 2 into 2, 4, and 3 into 7, 21. Altogether, you can check it, 57. So this is the final answer after multiplying these given two matrix. Okay. So I think it's okay. And right. So in here again another thing or another rule in here, right? If matrix is a matrix, when we multiplying by the identity matrix, right? We can get the same one, right? To make a this is the identity matrix, no, right? When we multiplying by the given matrix, we can get the same, because you can see when we multiplying this one 31, next one we multiplying by 0, it becomes 0. That means only we can get that is 36, right? So when we taking it second, it's the same, right? 1 into 21, 21, when 0 into, 1 into 30, sorry, 1 into 21, 21, 0 into 57, 50, 0, right? So however we can get this value, you can go through it, right? So it is very clear, because we need to manage our time, right? So I will move to the next one. So yeah, this is some another metric operations, right? So I think you can check it following my materials already uploaded into the LMS, right? So if we are multiplying by the any matrix with the identity matrix, we can get the same one, right? And also if there is a three matrix like A, B, C, when B multiple C and when multiplying by A, it should be equal to A multiple B and C, like that. Okay, so so you need to go through this one and try to understand, right? And next one I want to, because here I want to show you how to add the given simultaneous equations, right? So solve simultaneous equation by using this matrix, right? So then one more thing in here, yeah, T mean transform, no? Yeah, no, here T mean what? T is the name of the matrix. No, it is given two matrix. You can see if the matrix T is 1, 2, 5, 0 and matrix S is 3, 4, 0, 2, then we multiplying these two. That is very important one, right? When we multiplying these two, T and S, we can get this one, right? So here, what is the thing we need to understand? No, I want to emphasize you, right? If we multiply by S into T, right? When we write in the matrix X first and then T, then we can get the another different answer, right? These two is not similar. AB not generally equal to BA, right? BA may not be conformable, right? So you can check it, right? මේ දෙක වැඩි කළාම ඕගොල්ලන්ට 3 and right? 0, it's 3, it's the answer, and then 4, right? And here 4, 2 into 2, 4, then altogether 8. This 15 you can get 5 into 3 because this one become the 0. And this 20 you can get multiplying by 5 into 4, 20, 0 into 2, 0, right? Like that, other one you can understand, right? Next one. So then, so this is one of the operations, right? You can go through this one because multiplying by the identity matrix, right? And yeah, this is another important one, transform, right? Transpose of matrix. The transpose of matrix is one of the most common method used for matrix transformation in matrix concept across linear algebra, right? So this transpose of a matrix is obtained by changing the rows into the column and columns into the rows for a given matrix, right? It is especially used in application where inverse and adjoint of matrix are to be obtained, right? I'll show you this very easy one, right? Yeah. Okay, so if our matrix is this one, right? You can see 2 into 3, right? After we transform matrix, it's 2 into 3 because it's transform, right? Because then this row become now column, right? After transpose. This row become another column, right? You can see it, right? Here 247, now 247 this side. The 531, then 531 this way. Okay, so this is the transpose of the matrix, right? So it is okay then. And then matrix operations, right? So I have given same that's transpose, right? These are the some examples, right? One more example, you can go through this one, right? Then you can see it, right? After transposing, the size is changed, right? 2 into 3 become 3 into 2, right? Column එකයි row එකයි මාරු වෙනවනේ. And these are the properties of transform matrix, right? You try to understand this part also, right? And this one, yes. Yeah, A plus B, if it is A, this is B, then uh, trans, yeah. So we can add these two together, then we can get it, and then we can transform, right? Or same thing we can get, we first transform the first matrix, and then transform the second matrix, and then after we add in these two, the same answer we can get, right? So both are equal. And yeah, this is another example for same thing, right? So if this is the first matrix, this is the second matrix, right? So then we can multiply these two together, right? Try when we multiply in these two together, we can get this 2, 8 matrix. Then we can transform it. Then the final is 2, 2, 8. Or you can get this first matrix transform and second matrix transform this way, and then multiply by these two, right? So go through this one and symmetric matrix, right? So then this is the square matrix is symmetric if it is equal to its transpose, right? දෙක equal නම් අපි එහෙම කියනවා. So inverse matrix, this is very, very important one because this one is also we can apply when we solve in simultaneous equation, right? Inverse of matrix. This is very important. So I will show you one example. I will, yeah, give me 1 second. I will take one more slide like this. Mm. Yes. Like PPT. Insert. Okay. Now, so I, I think now it's sharing my empty slide, so now I can write. You can see it. Okay. So then inverse, right? Inverse of matrix, right? So this is the general form of the inverse of matrix, right? If our matrix is A, right? Uh, element I put this way, A, B, N, if it is the 2 by 2 one, A, B, C, D, right? So suppose our 4 element of the matrix is this one. So then inverse X, right? Inverse X mean, right? This is the inverse X, the way how we can show it with the notation, right? So then 1 divided by AD, right? Now you can see in here the common way AD, that means you have to multiple AD, A value in our given matrix and D element, right? A and D element. Then minus B and D, right? B and D, right? B and, sorry, B and C, right? B and C, okay? B and C. Then multiple by it, right? We have to change A and D, right? Because now we need to write D in here and A in here. And this C and B, we need to change our given already original sign, right? Instead of B, now minus B. Instead of C, now minus C. Okay. So after multiplying these T, we can get the inverse of this matrix A, right? Shall we do one example now? Right? One more example. So, any, yeah, yeah, this is the one matrix A, right? So it's a sample matrix. Just think our A is equal to, suppose our A is equal to 1, here 2, second element, third element again 2, and shall I put in here 3? Right. Okay. This is, if suppose this is our given matrix, right? So then how we can get the inverse, right? So very easily you can get that inverse matrix, right? Inverse one of this A, right? According to the given formula or given method, 1 divided by AD, right? Here AD means, you can see A is 1, right? D is 3. Then 1 into 3, 3. Right? And then minus B into C. In my case, B is 2 and C is 2, right? Then 2 into 2, 4. Okay. And then we need to multiply by it after changing this way, right? D and A change. Enang api 1 2 change karana. Then it's now 3 and 1. Okay. And BC same, but we have to change their sign. Instead of 2, now minus 2. Again, instead of 2, minus 2. Okay. So then finally we can get the inverse matrix when multiplying these two, because 1 divided by, here we can get the minus 1. 1 divided by minus 1 means minus 1. That means all the elements inside the bracket we have to multiply by minus 1, right? To get the inverse x, right? That means minus 3, this one plus 2, this one plus 2 because already minus no. This one minus 1. Okay. So this is the inverse. This is the inverse matrix of the given matrix A. Right? Inverse matrix of the given matrix A. Right? So then, shall I move to the next one? Right? Okay, so next one. Uh, yeah, so now I would like to explain you how to solve the simultaneous equation by using this matrix, right? By using this matrix. So, shall we take one example section, right? Sample section. Two equations, right? 2x plus 3y, okay, equal to 4. This is the equation 1, right? And second equation, 3x plus 2y equal to minus 4, right? So then my question is solve this simultaneous equation using matrix, using inverse matrix, right? Using inverse matrix, right? So then as the first step, we have to uh, as the first step, we have to write this one, the multiple both side with the inverse x, right? Inverse x. So, shall I write? So, but first of all, we can identify these figures, right? With this way. That means A is the first, we can write the matrix with using the coefficient of the two equations, right? Here you can see 2 is the first equation coefficient. Then y's coefficient is 3. Then second one x coefficient equation is 3 and second equation coefficient is 2. Okay. So then we can write x as the our xy, right? Xo, you can put in any unknown variable name, but this here our two unknown variable we have to find out, right? And B we can write it for the B matrix is the right hand side value of the given two equation, right? We can write it 4 and next minus 4, right? Now we have three matrix, right? One has with the number, so the variable, other two has the number, right? Other two have the number. And then here we can write this one A multiple by X, right? AX equal to B, right? Because this is equation sign, right? These two equal to B. Okay, so B. So then when we take in inverse one, right? So first we can get the inverse x of the A, right? So this inverse A, right? Inverse A. Now we know how to get the inverse A. How? We can get it, right? Did you remember the way? Right? So first we need to divide 1 divide by, did you remember? A and D, right? In our case, this is A, this is D. Then 2 into 2, 4, right? A and D minus B and C. B and C is our 3 and 3, no? B is 3. Our case, C is also 3. 3 into 3, 9, right? Okay, so then we have to apply. Did you remember how we get the inverse one, right? So A and D we need to change, right? A and D we need to change, right? A and D. So now A this one, D this one, but fortunately both are same. So therefore, if we change in this two, again same, right? Dekama deka dekani change. But B and C, we have to change their sign, right? Already here -3, then +3, then we have to put here -3, and here also -3, right? Then we can get the inverse A, right? Inverse A mean when we simplifying this one, 4 minus 3, 1 over -5, no? -1. So that means here 5, okay? Minus, okay? Then we need to multiply this with this minus 1 over 5 with these two. -3 and 2, no? Now take the value, right? We can get the value. 1 over 5, that means 2 over -2 over 5, no? When we multiply. Next one multiplying 1 over 5 minus minus, then it become plus, no? Then it is 3 over 5, right? 3 over 5. Yes. Okay. It is 3 over 5. And next one, minus minus again plus, then again 3 over 5, no? 3 over 5. Next one, minus plus again minus, 2 over 5, no? 2 over 5. Okay. So this is the inverse one, inverse matrix finally we get. And then we multiplying this one with our B, we can get the answers for our X and Y, right? So then we need to multiply by this one, our matrix B. Matrix B is, you have seen in here, 4 and -4, right? -4. So did you remember now? Uh, First we need to get the inverse A and then multiply by it our B matrix, right? So then X and Y we can get in order, right? In order. So we need to multiply these two matrices, right? So then yeah, I'll show you it. Okay, so now to get the final answer, we have to multiply these two, right? That means we can get our X and Y, right? X and Y in this order. Okay, so just try to multiply this one, right? When we multiply in these two equations, right? You can see first we need to multiply by this one by this 4, right? That means -2 over 5, right? Multiply by 4, and same time we have to add other part, right? What is the other part? We need to multiply this one by this, okay? So that means add, okay, add uh, -2 over 5 into -4, right? Into -4. Okay, so then with that we can get the one value, right? And the second one we can get multiplying this one and this, and sorry, this. No, we can get 5 over 3 multiplied by 4 and 2 -2 over 5 multiplied by -4, no? This one and this one. So shall I write it in here? Bracket 3 over 5 multiplied by 4. And then plus minus 2 over 5, right? 2 over 5 here minus 4, no? Making a different multiple by again minus 4, right? So then we can get the x and y answer. Shall I write in here? X is upper one, lower one, y, right? So now try to answer. Here 2 into 4 minus 8 divided by 5, right? Pahing attack. Here minus minus plus. Again 3, no? So here this one is 3, no? 3 into 4, 12, no? It is again become plus. Okay. No. Yeah, plus. Then 3 over, sorry, this is 3 over 5 is minus. This is also minus. 8 over 5 minus, 12 over 5 minus, all together 20 over 5 minus, no? So the 20 minus 20 over 5. That is the first one. Second one, minus 12 over 5. Okay. And here, minus minus plus 20 over 5. 20 and, yeah, 20 here, 12, no? This is, let me check this one and this one when we multiply. This is plus. Then this is plus 4, no? Sorry, this is plus 4. Then it is plus value. Again here minus minus, again plus, no? Then plus plus mean again 20, no? You can check it 20 over 5. Okay. So now minus 20 divided by 5 mean minus 4. Here 21 plus 4, right? So these are the answers for x and y, right? X and y. That means x equal to minus 4, y equal to plus 4, right? So after we simplify, solving these two equations with using the matrix, right? Especially here we use the inverse matrix, right? So we can get the answer. So then you can, if you need it, you can check whether you are correct or wrong when substituting this value into your original equation, right? Original equation. Okay, so this is x is minus 4. So, instead of x minus 4, them with 2 into minus 4, then minus 8, and 3 into y is plus 4, no? Right? So then we can get plus 12 and minus 8. Then this 4, okay. So same, like same, you can also check it with using this equation, right? So x is minus 4, then here minus 12, no? 3 12. Then y is plus 4. Devara 4 8, right? Here plus. Plus 8 and minus 12 again minus 4. That means already we obtained answers are correct, no? So that this is the way how we can solve the very simple simultaneous two equations by using matrix. Okay. So I think these things you can further study with support of your already uploaded notes in the LMS, right? So then I am concluding this session now. Okay.